He did not consider the protective layer. Let's again look at the lower straight length. As we calculated earlier, the lower straight length is equal to the member minus the straight length and minus horizontal projection. That is the lower straight length. After calculating the lower straight length, some classmates might calculate wrong here, because if he made a mistake earlier, the rebar here may have been miscalculated. If there is an error in the calculation, the rebar calculation was incorrect. For example, if the value for the rebar was calculated high here, that is unacceptable. If your calculation is too high, this will make it difficult to install the rebar. Installing certain rebars can be challenging. When the installation process becomes challenging, this will cause what problems? The installation quality is very poor. For example, the rebar is misaligned. It is impossible to install some rebars, so the workers might leave it uninstalled. The rebar might short in quantity, even missing. When the rebar for such member is short in quantity, missing, what will happen then? Unsafe. Its stress bearing will be affected, because the main function of the rebar is for stress bearing. If it was missing, force is insufficient, the member might broke, or some parts of the concrete might failed, because there is no rebar for our concrete. When there is a quality issue, and we need to trace to the source one of the trace point, maybe our rebar calculation was wrong. The rebar calculation was wrong. After finishing the calculation of the lower straight length, you can get the entire straight length. Then we can calculate the cutting length of the rebar. For the cutting length of the rebar, except the straight length, there is also a diagonal length. We just calculated the horizontal projection of the diagonal length, so we can calculate its diagonal length quickly, which is the horizontal projection multiplied by square root of 2. Just this one. Multiply by 2, same as the calculation earlier. A 2 by 6 was missing here, and then multiply by a square root at the end. You just put this here. It is the horizontal projection of the diagonal. Multiply by the square root, it's done. Why multiply by the square root of 2 instead of the square root of 3? Isosceles right triangle, isosceles right triangle. The angle is 45 degrees. We can use the Pythagorean theorem. It is 1:1. The cutting length of the rebar. Here, there is one more mistake. In his calculation, the classmate used the bending adjustment value for bent-up reinforcement. What was it? For by 2.5 by 25, when using x 2.5, it is more likely that he thinks the angle of the bent-up reinforcement is 135 degrees. Let's take a look. The angle of the bent-up reinforcement is 135 degrees. Then the angle of the bent-up reinforcement is 45 degrees, or 135 degrees. I used to tell everyone, a concept which can be used here. Inertia. Everything has inertia, including inertia thinking. What is inertia? Just like Newton's second law, the law says things will remain still, unless it is given an external force. It's the same here, it's all inertia. Actually, it can be understood as inertia. Like the rebar here, it will come straight down according to inertia. Then it will bend at a 45 degrees angle. Diagonal segments are also like this, and it will go up diagonally according to inertia. So, how do you bend upward? 45 degrees is based on inertia. The same applies here. You can obtain inertia similarly. Attention, remember this inertia and you won't be prone to making mistakes in the future.